Hello and welcome to this video on perimeter and area. This is part of our Functional Skills Maths Level 1 and Level 2 course. The learning outcome for this lesson is to define and calculate perimeters and areas of simple and compound shapes. The linked learning relates back to the last lesson on 2D shape and shape properties. Remembering things like the properties of a rectangle, where the lengths at either end and opposite are the same length, will help us calculating perimeter and area. Let's start with perimeters. And the perimeter is the distance around the outside of the shape. Let's look at a couple of basic shapes and create some lengths so we can work out the perimeters. So with our square, the properties of a square are that all of the sides are the same length. So if one side is 5 centimeters, our perimeter is going to be 5 plus 5 plus 5 plus 5. Or if you wanted to, you could multiply 5 by 4, whichever you prefer. So 5 plus 5 plus 5 plus 5. So we're walking around our shape, and that gives us 20. And the distance, because it's just in one dimension, is 20 centimeters. For our rectangle, we need to know two of the dimensions so that we can work out the perimeter. So if I say this side is 6 centimeters long and this side is 4 centimeters long, because of the properties of a rectangle, I know this must be 4 and this must be 6. Now when I walk around my shape to work out my perimeter, I get 20 centimeters. Notice the units are just centimeters because we're measuring just one dimension, which is length. Now let's look at the perimeters of triangles. Now, depending on the properties of the triangle, depends on what you are given to work out the perimeter. So if you're given a scalene triangle where all of the sides are different lengths, you would have to be given all of those lengths. So this would be 3 centimeters, 4 centimeters, and 5 centimeters, so that you could walk around the shape and add 5 to the 4 to the 3 to get 12 centimeters as the perimeter of our scalene triangle. Now, remember the properties of an isosceles triangle, that these two sides are the same length and that these two angles are the same. So in theory, to work out the perimeter of an isosceles triangle, you need to know the size of the base and one of the isosceles sides. So if this was 4 centimeters and this was 2 centimeters, then you'd have this as 4 as well. So 4 plus the 2 is 10 centimeters as the perimeter of our isosceles triangle. The properties of our equilateral triangle are such that all of the sides are the same length and all of the angles are 60 degrees. Now to work out the perimeter, we only need to be given one of the lengths. From that, we know the other two lengths. So if this is 4 centimeters, then the thing that isn't being said is that this and this side are also 4. So our perimeter would be 4 plus 4 plus 4 equals 12 centimeters. Finally, our right angle triangle, yes, it's got the right angle, but a right angle triangle can either be scalene or isosceles. So you just need to be careful of these two lengths. If they're the same, then it's an isosceles right angle triangle. If they're different, it's scalene. You need to be given all of the lengths. So this would be 5, this would be 4, this would be 3. So your perimeter would be 12 centimeters. So to work out the perimeter of a triangle, you need to be aware of which triangle you're dealing with. Now, to work out the perimeter of complex shapes, you sometimes might not be given all of the sides. If you're level 1, possibly they'll give you the length of each of the sides of your complex shape. If you're level 2, 1 or 2 of the sides will be missing. So the best method for working out the perimeter of a complex shape is to pick a corner and walk around the shape and fill in the blanks first, and then walk around the shape and add up the numbers. Let me show you what I mean. If we assign lengths to most of our sides, we can calculate our missing sides based on some of the measures we already have. So if I walk around my shape and I start here and walk around my shape, I know I've got 8 centimeters and 4 centimeters, but this length here is missing, this length here is missing, then I've got 4 and 7. So I've got 2 lengths I need to find. Now, to find this missing length here, I need to combine this length here, which I know is 8, and take away this length here, which I know is 4. So this length is 4 centimeters. The same for this missing length here. Now it's the same for this missing length here. If I know the distance from there to there is 7, and that the distance from here to here is 4, then this missing length must be 7 minus the 4. So that's 3 centimeters. So now, when I walk around my shape, I've got all of the sides that I need to work out my perimeter. So starting at my start point, I've got 8 plus 4 plus 4 plus 3 plus 4 plus 7, giving us a total of 30 centimeters. So the perimeter for this shape is 30 centimeters. Now, this L shape for a room or a garden is very, very common in functional skills exams. A less common complex shape are these T shapes. So see if you can have a go and work out what the missing sides are and what the perimeter is of this complex shape. Now, don't forget our process. Pick a start point and walk your way around the shape, working out any missing sides as you go around. So this is 8 centimeters, and then we go up, that's 1 centimeter. Now we're missing this side here, from here to here. Well, it's the same length as there to there, so it's 4 centimeters. Then we have 5 centimeters here, then 4 centimeters, and we're missing a length there. Now, we know the total distance is 8 centimeters. We know we've got 1 centimeter there, and then another 5 there. So this means there's 2 centimeters missing to make up the 8. So this side here must be 2 centimeters. And the final side here is the same as the one below it. So again, that's 8 centimeters. To find our perimeter, so we come back down, we've got our final 8 centimeters there. Now to find our perimeter, we walk around our shape. So we've got 8 plus 1 plus 4 plus 5 plus 4 plus the 2 that we found plus the 8 that we found, and then the final 8 to get back to the start. And this gives us a perimeter of 40 centimeters. Did you get the correct answer? Another very popular compound shape that they like to give you in exams are these U shapes, where you have a little cutout missing on the shape like this. So you have your big area and then your little sort of cutout on it. Okay, so let's have a look at how to address that. So have a look at this problem. You'll always be given enough information to fill in the blanks, and to work out the perimeter, just walk your way around, pick a start point and fill in the blanks, and then add all of the lengths together. Let's do that now then. So if the bottom is 12 from here to here, then as I walk round, the distance, if I go around this way, from here to here, must be 8, because we have 8 over here. So that's 8 centimetres. We've got the 3 across the top, and then we come down this way. Well, if this one over here is 2, this must be 2 centimetres as well. Then this gap here is made up of 3 up to there, 3 up to there, so that's 6 out of our 12, so this must be 6 centimetres in that gap. We've got the 2 here, the 3 there, the 8 there, and then the 12 to get back to our start point. So we've walked around the shape and we've filled in the blanks. All we need to do now is add them up. So we have 8 plus 3 plus 2 plus 6 plus 2 plus the 3 plus the 8 plus the 12. So I'm walking around filling in the numbers as I go around. Add this together and you get 46. Don't forget the units are centimetres. Okay, let's have a go at some basic shapes. So here they've given us a rectangle, so we know this is 18 and this is 13. So our perimeter is 18 plus 13 plus 18 plus 13. And that gives us a perimeter of 62 centimetres. Notice how I give the units every time I give an answer. Here's another one to have a go at. Now, don't forget the process. Walk around the shape. So if I start here and walk around my shape, I know this is 6.5, this side is 7.2, and this side is 4. I've got a missing side here that I need to work out the length. Now the full height from top to bottom is 7.2, and I know from here to this corner is 4. So that leaves 3.2 meters for our missing length from here to here. And again, we're missing a length for this side. So I know the full width is 6.5 meters, and I know from here to here is 4 meters. So that leaves 2.5 meters from here to here. And as we continue round, now we've found our missing lengths, we've got 4 meters and back to the start. So to work out the perimeter, we need to walk around our shape. So 6.5 plus 7.2 plus 4 plus 3.2 plus 2.5 plus 4. And that gives us a perimeter of 27.4 meters. Did you get the correct answer? Okay, here's another complex shape for you to have a go at. So pick a start point, walk around and fill in the gaps, then walk around again and make sure that you add everything up to get your perimeter. So if we start in the bottom left here and we go this way, we have the 5 here, the 7, then over here, this length from here to here must be 5, it's the same as the other side. We have 1 meter here. We've got nothing on this one, so we need to put in the 3 meters because it's the same as over there. We have 1 meter there, and then this final length from here to here. Well, if I've got 1 there, another 1 there, that's 2 out of the full length of 7. So that must be 5 meters there. Now we've got all our lengths, let's walk around and add them up. So I've got 5 plus 7 plus 5 plus the 1 plus 3 plus another 1 plus the 3 and then plus the 5 to get me back to the start. And that's a distance of 30 meters. Okay, sometimes they'll give you a perimeter question in functional skills that does not involve a picture. So here, Jenny has put a fence all around her garden, which is 22 metres long and 11 metres wide. How many metres of fencing does she need? So basically they're describing a rectangle. Don't be frightened of making your own sketch. So you've got 22 metres by 11 metres. Don't forget we've got another 22 and another 11 because she's describing a rectangle. For your perimeter, add the 4 lengths and you get 66 metres for the perimeter, or the amount of fencing that she needs. Now let's look at area of basic shapes. And the area is defined as the space inside a shape. Now we've put a reminder here for the units because we're now talking about combining 2 dimensions. Our units are going to be squared to show that we're dealing in 2 dimensions. That's what the squared is on the units, telling you we're dealing with 2 dimensions. At level 1, sometimes you're given area questions that involve centimetre squares. So all you really need to do is to count the number of squares. So the area of this rectangle is 1, 2, 3, 4, 5, 6, 7, 8. It's 8 centimetres squared. If you're doing level 2, you're not likely to get the unit squares. So you'll get a measurement of 4 centimetres here and 2 centimetres there. So to get the answer for the area, you multiply the 2 dimensions to get area. So 2 times 4 is 8 centimetres squared. And this is how we're going to do the majority of our area calculations. Now, to calculate the area for basic shapes is combining the 2 dimensions. So for a square, if I gave you one of the dimensions, you automatically, because of the properties of a square, know the other dimension. So if one side is 5 centimetres and the other is 5 centimetres, so to calculate the area, multiply the 2 dimensions to get 25 centimetres squared. So don't forget where our square numbers come from. They come from literally creating a square. Now if you have a rectangle, you just need to combine the 2 dimensions. So if this is 6 centimetres and this is 4 centimetres, then to work out the area, you need to combine these 2 dimensions. So 4 times 6 is 24 centimetres squared. So notice I'm putting the little 2, the square symbol, next to the units. If you put it next to the number, that means something totally different in maths, like this. So notice it's the units that show the square to show we're talking about areas. So 25 centimetres squared shows me I'm talking about an area. 24 centimetres squared show me I'm talking about area. Now, to calculate the area of any of the types of triangles, you need to multiply the base by the vertical height. So the base times the vertical height. It doesn't matter which type of triangle you have, it's these 2 dimensions that will give you your area of your triangle, but you then need to halve them because a triangle is half a rectangle. So you need to multiply the base by the vertical height and then you need to divide it by 2. So if the base was 10 and the vertical height was 8, then it would be 10 times 8, which is 80. So you've combined your 2 dimensions. But because it's a triangle, we need to divide by 2 to give us 40 centimetres squared as our area for our scalene triangle. Now with all of these lengths, they will have to give you the base and this vertical height. You won't have the skills in functional skills to calculate these for yourself unless it's really obvious on a right angled triangle. So with our isosceles triangle, if the base is 3 centimeters, the height is 6 centimeters, then the area is going to be 6 times 3, which is 18, and then divide it by 2 to give you 9 centimeters squared as the area. Now with the equilateral triangle, these lengths are different. Even though the sides are the same, this vertical height is a different length. So if you were given the base of 12 centimeters and a height of 10 centimeters, then it would be 10 times 12 to give you 120, divide it by 2 to give you 60 centimeters squared. And finally, the only one that gives you the sides to work out the area is a right angled triangle. So if they give you one of the sides here, which is 10 centimeters, and the base, which is 4 centimeters, then the area of that triangle is 10 times 4, which is 40. That's the 2 dimensions. And then don't forget to divide by 2 to give you 20 centimeters squared. Now, if you're given areas of complex shapes, the trick is to break the shape into basic shapes. So with our classic L shape, we might not need our missing 2 sides. Let's calculate those later, should we need them. So we can divide our shape into 2 to make 2 rectangles, depending on which way we want to divide them. So if we divide them that way, we have the 3 millimeters that way, but we'll need to find this missing side. We have the 5 millimeters that way and the 8 millimeters that way. So we have the 2 dimensions we need to calculate it. Conversely, we could divide our shape this way, in which case we have our 3 millimeters by 12 millimeters that way, but this way we have our 8 millimeters and we need to find this width here. So let's do that. If the full width is 5 and the width up to here is 3, then this must be 2 millimeters. So our 2 areas for our 2 rectangles are going to be this bit here is 8 by 2, which is 16 millimeters squared. This rectangle here is going to be 3 millimeters by 12, which is 36 millimeters squared. All we need to do to find the area is add the 2 together. Have a go at this problem. The reason I've given you this problem is because it's a very popular one in the exam, because it looks like a wall with a door cut out of it, like it's got like a door frame, and these are very popular for working out the area that needs to be painted and so on. So work out the area of this complex shape for me. So don't forget the process, which is work out the big area, take away the small area. Okay, so the big area is 7 meters by 5 meters, which is 35 meters squared. The small area, which is the door frame, is 3 meters by 1 meter, which is 3 meters squared. Take one from the other, and you have the area of the shape is 32 meters squared. Sometimes to calculate areas, you will not get a diagram, they'll just give you the problem in words. So Natalie is buying a carpet for a room that measures 7.5 meters by 4.5 meters. How much carpet does she need to buy? So quite literally, our 2 dimensions for our carpet are 7.5 by 4.5, so we need to multiply our 2 dimensions. And we end up with 18.75 meters squared. Now, when we did the first lesson of the course, we talked about something called a factor. Now, when you're trying to work out the dimensions of an area that's been given to you, then it's the two factors of that area that can be the length of the two sides. So in our example here, our area is 30 meters squared, but we don't know what our two dimensions are. So if we go back to our lesson on factors and break down 30 as factors, then the two dimensions that can give us our 30 meters are 1 by 30, 2 by 15, 3 by 10, and 5 by 6. So it allows us to create the area, the correct area, using a combination of dimensions. Here's an example of a question using that particular skill. So Bruce needs a chicken pen with an area of 40 meters squared. He measures his back garden and it's 10 meters long and 8 meters wide. Suggest some dimensions of the pen that he could use. So using our factors of 40, we can see the combinations that will fit into his garden. So you can't have a chicken pen that is 1 meter by 40 meters because it would go outside the dimensions of his garden. You can't have a pen that is 2 meters by 20 meters because again, the 20-meter length would be outside his garden. So the two chicken pens he can have is one pen that is either 4 meters wide and 10 meters long, or a chicken pen that is 5 meters wide and 8 meters long. So these are the two options for the chicken pen. Now we're going to talk about tessellation, and this is just a posh maths word for tiling. Now, you'll need to understand tiling because generally when you get an area problem, they're going to give you a small thing that's going to go into a big area, just like the tiling effect. So there are two methods to do tiling. One of the methods could be that you look at the dimensions of the tile and you work out you need 5 that way and 5 that way to give you 25 tiles. Now this is a very visual thing and it works when you have very easy areas of tiles and the main area and when they're in the same units. However, the best way to deal with all sorts of tiling questions is to work out the area of your big object. So 10 times 5 equals 50 meters squared, and the area of your small object, which is 1 times 2, which is 2 meters squared. Make sure they're in the same units and then divide one by the other, the big area by the little area, and that will tell you how many tiles to use. And this need to be in the same units is really, really important and something you get tested on a lot. So we have a big area here in meters and a small area of our tile in centimeters. So before you do the calculations, make sure they're in the same units. So I'm going to work in meters. So my big area is 6 times 9, which is 54 meters squared. My smaller area, I need to convert before I calculate the area. So 50 centimeters, knowing my conversions, I'm going from a small unit to a big unit, and I need to divide by 100 to get meters, is 0.5 of a meter. So my area for my small tile is 0.5 times 0.5. Can you see where that little trick of multiplying a little decimal by a little decimal comes in? Okay, move the decimal points. 5 times 5 is 25, and then put the decimal points back. So the area of the small tile is 0.25 meters squared. So to work out how many tiles, take your big area and divide it by your small area. And this gives you 216 tiles. Here's a little activity that you can have a go at. You want to build a patio area 4 meters long and 3 meters wide for your garden. Your local DIY store tells you they sell suitable planks of wood that are 2 meters long but 25 centimeters wide, and they cost £3.95 each. Work out the patio area, the area of each plank, the amount of wood you'll use, and the total cost of wood. So let's start off with the patio area. So the patio is 4 meters by 3. So if we do that, then we've decided that our units are going to be meters squared. So everything needs to be in meters. So for the plank, I've got 2 meters by, now 25 centimeters needs to be divided by 100 to give 0.25 of a meter. So to work out the area of the plank in meters, it's 2 times 0.25, which is 0.5 of a meter squared. Work out the amount of wood you use, so take your big area and divide it by your little area, and it tells you you need 24 planks. And then finally, to cost it up, £3.95 times the 24 planks equals £94.80. And this is a typical functional skills question on big areas, little areas, and costs. Now there is one basic shape I've avoided talking about so far, and that's because it's for level 2 students only, and that is the circle. Now before you can do the perimeter and area of a circle, there is some basic terminology that you must get correct in your head. Can you label the parts of the circle here in red, blue, and green? Now, the parts of the circle that you need to know. The circle itself, or the distance around the outside of the circle, is called the circumference. So it's a posh word for a perimeter of a circle. The diameter is a straight line that goes from one side of the circle to the other through the center. And then finally, the radius is a line that goes from the edge of the circle to the center, and the radius is half the diameter. So if we multiply the radius by 2, we get the diameter. Now this is quite important because it's something they'll test you on. When we come to give you the formula for the perimeter area of a circle, when you want the radius, they'll give you the diameter, and when you want the diameter, they'll probably give you the radius to check your understanding of these two terms. So let's look at the perimeter of a circle, commonly known as the circumference. Now, a Greek scientist many years ago found that whenever he drew a circle, there was a relationship between the distance around the outside of the circle, the circumference, and the diameter. It produced a constant number no matter how big or small the circle was. This number he called pi, which is 3.14. So whether he drew a circle as small as a 5p piece or as large as a football pitch, whenever he divided the circumference by the diameter, he got this magic number of 3.14. So knowing that these two things were constant, he came up with a formula that tells us the circumference of a circle. So the circumference of a circle is equal to pi, this magic number, times the diameter. That's what these two together mean. So remember our lesson on formula. When you get a number and a letter, or a letter and a letter close together, then the only thing that can fit between them is a multiply sign. Now you need to remember this. You're not going to be given this in the exam. So as a level 2 student, you need to remember the circumference of a circle is equal to pi times the diameter. Now pi is a constant that in your exam will be the number 3.14. So every time you have pi, you swap it for the number 3.14. The diameter is whatever the diameter of your circle is. Now remember, you need the diameter, not the radius, to put into this formula. So let's try it with a few basic circles. So find the circumference of these circles. So as a functional skills level 2 student, you need to remember the formula. The circumference is equal to pi times the diameter. This is always going to be 3.14, and we've given you some circles here with different information to allow you to work out the circumference. So let's look at this circle to start with. Our circumference is equal to pi d, so it becomes equal to 3.14 times 5. Now they might give you this in paper 1 without a calculator, because it's a sort of calculation you can do. And you get 15.7 centimeters as the circumference of this circle. For the next one, let's do this one over here. The circumference is equal to 3.14 times the diameter, which is 7. So the distance around the outside of this circle is 21.98 centimeters. Finally, let's have a look at this circle. So our circumference is equal to pi d, where pi is 3.14. Now, the diameter is the distance from side to side, and they've given us the radius. So to find the diameter, we need another 4, or we need to double the radius. So the diameter is 8 meters. So that gives us 25.12 meters for the circumference of this circle. Here are 2 functional skills questions on circles. A circular teepee tent is 3 meters across the base. In other words, the 3 meters is the diameter. What is its circumference? So you have to remember C equals pi d for circumference. Pi is the number 3.14, and we've worked out that the 3 meters across the base is our diameter. So it becomes, the circumference becomes 3.14 times 3, which is 9.42, and don't forget the units of meters. Don't forget, it's a measure of distance, the distance around the outside of the circle. Let's look at our next question. A hula hoop is 90 centimeters across. What is the length of the plastic needed to make it? So we know that the circumference or distance around the outside of the hula hoop is equal to pi d. I know pi is 3.14. I know I have to multiply the two things together, and the diameter is 90 centimeters. It's the distance across the hoop. So our circumference is going to be equal to 3.14 times 90. and that's 282.6 centimetres, which is our length of plastic. Now let's look at the area of circles. Again, it's level 2, and again, you need to remember the formula for this. So the area of a circle is that magical number pi times the radius squared, and we know what squared means. So the radius is the distance from the center of the circle to the edge. It's half the diameter. Let's do a basic example over here to see how it works. So the area of this circle is pi r squared. So it becomes 3.14 times the radius, which they've given us, 8 squared. So 3.14 times 64. That's what 8 squared is. BIDMAS tells us to do the index first. Now we have 3.14 and we multiply it by 64. And we get 200.96. The units are centimetres, but because we're talking about area, the units are squared because we're talking about the result of 2 dimensions. Here are 3 examples for you to have a go at. Remember, you need to remember the formula for the area of a circle. So if we look at the first one, the area is equal to pi r squared. We know pi is this number 3.14 times the radius is 5 kilometers, but don't forget to square it. So it becomes 3.14 times 25, which is 78.5, and it's kilometers squared is our area. Let's look at the one below it. So our area is equal to pi r squared, and we know that pi is the number 3.14. Next to the r means we multiply, and then the radius they've given us here is 20 meters. And don't forget to square it. So it becomes 3.14 times 400. And that gives us an area of 1,256 meters squared. Finally, the tricky one. So our area is equal to pi r squared, and we know pi is 3.14 multiplied by the radius. Now they've given us the diameter, so the distance from the center to the edge must be 1 centimeter, so it's 1 squared. This becomes 3.14 times 1, because 1 times 1 is 1, and that gives us 3.14 centimeters squared. Here's a slightly harder functional skills question on areas of circles. A handmade circular tablecloth measures 100 centimeters across. So essentially that's our diameter because it goes from edge to edge. And it consists of a cloth circle with a lace border. The inner section measures 60 centimeters across. So that's across the center of our circle here. What is the area of the whole tablecloth? So let's do A first. So to do A, our area is equal to pi r squared. So pi is 3.14, and the radius of our tablecloth is half this diameter, so it's 50 squared. So it becomes 3.14 times 2,500. Put that in your calculator if you want to, and you get 7,850 centimeters squared. Then we need to work out the area of the inner circle. So this inner circle we've got here. So for B, the area of the inner circle is equal to pi r squared. Pi we know is 3.14 times, because they're together, and then the radius. Now they've given us the diameter, so the radius is going to be 30 centimeters, and we need to square it. So our calculation becomes 3.14 times 900. Work this out and you get 2826 centimeters squared as the area for your inner circle. So now to find the area of the lace border, so this bit here, we just take our small area circle from our big area of the table, and it will leave the area of this grey area around the outside where the lace is going to be put. So for part C, we just need to take the 7850, the big area, take away the small area, 2826, and that gives us 5024, and that is centimeters squared. Now there is something else I need to tell you about pi and how we do calculations in the non-calculator paper, and that is that pi can also be represented by a fraction. So the fraction 22 over 7 is very similar to pi. Let me show you on our calculator. So if we call up a fraction and we put 22 as our numerator, 7 as our denominator, we press equals and the SD button, you get 3.14. So sometimes it's better to use pi as the fraction 22 over 7 to do calculations. And really, it depends on what your diameter or your radius is in the question. Now, if you get a question in paper 1, they might actually tell you pi is 22 over 7, and it's a big hint on what they want you to do. Let me show you. We know that the circumference is equal to pi times the diameter. So if we say the diameter is 14, doesn't matter what, 14 centimeters, we end up with C equals 22 over 7 times the diameter, which is 14. Now, going back to our week 4 lesson on fractions, we know that we don't do this, we do this. And what you will find in your non-calculator paper is that 14 divides by 7 really easily. So it's 2. So our answer would be 22 times 2, which is 44. Now, it's the same for the area. Sometimes they will give you a radius that is divisible by 7. So in this example, find the area if r is 7. So we know the area is equal to pi, which we're being told is 22 over 7, times 7 squared. Now in this instance, you can square the number if you want to, but what you can do is you can write it out in full, because I know 7 squared means 7 times 7. And then instead of doing that, I do this. 7 divided by 7 is 1, so our problem becomes 22 times 1 times 7. And we end up with 154. So here are a couple of questions to practice. So use pi as the fraction 22 over 7 and have a go at answering these two questions. Don't forget to pause the video and then press play when you're happy with your answers. Okay, for the first one, find the circumference of a circle if the diameter is 42 meters. So we know that the circumference is pi times the diameter, and we know pi is the fraction 22 over 7, and we've been given the diameter of 42 meters. Now, what you will find in the non-calculator paper is that 7 divides into 42 nicely. So 42 divided by 7 is 6. So it becomes 22 times 6. Now, don't forget you're in your non-calculator exam, so you can't go for your calculator on this one. You might have to do things manually. So you end up with 132, and the distance is meters for your circumference. Let's do the same for the area. So the area of a circle, find the area of the circle if the radius is 14 millimeters. So we know the area is pi times the radius squared. So pi is 22/7. The radius is 14 millimeters. And because we're squaring it, that means 14 times 14. Now what I can do is don't do that, do this. And then 14 divided by 7 gives me 2. So our problem becomes 22 times 2, which is 44, times 14. So let's do that. Don't forget, it's a non-calculator type question. And we get 616 millimeters squared. And that completes this video on defining and calculating perimeters and areas of simple and compound shapes. So for the perimeter of a basic shape, it's the distance around the outside. For a circle, you need to remember that that distance is called the circumference, and it's equal to pi times the diameter. For the area of the shapes, you need to multiply the 2 dimensions of the shape. For a triangle, you multiply the vertical height by the base and then divide by 2. And finally, you need to remember the area of a circle is pi r squared. And then just substitute the values you need into that to work out the area. Don't forget, with a circle, the diameter is the distance across the center. The radius is half of that distance, so from the center to the edge. And this thing called pi has a very special number, which you will use as 3.14. If you'd like more practice with working out perimeters and areas, please see your tutor. I hope this lesson has been of use to you. I hope you've enjoyed this video.